Hey everyone, welcome back to the Mates Mentor YouTube channel where we help you to learn, understand, and succeed in pharmaceutical science. I am Neelam, and today we are tackling an important concept neutralization curve. Whether you are in school or preparing for a career in pharmacy, understanding the neutralization and how to read the neutralization curve is essential for working with drug and chemistry. Then, ready in diving? Then grab your notebooks and let's get started. First of all, you saw neutralization curve. Okay, basically the neutralization curve is also called as titration curve. Neutralization curve or titration curve is a graph between pH of analyte and titrant. Titrant means your volume of your analyte. Then means in your y-axis pH, okay, and your x-axis volume of titrant added. Then as the equivalence point is reached, the titration, there is a rapid changes in color in pH. So that's why it's called as also the pH titration curve. That is even is equivalence. Before that, you had learned neutralization curve. Basically, some important terms we are clear firstly. Okay, the first is strong acid. Its name indicates that it is strong. Okay, so basically the definition, when you are any solute, okay, dissolved in solvent, they dissociated in water. Sorry, they dissociated in water. Solvent is used as a water. So solute dissolve in water, they completely release H plus ions. Okay, so it's called as strong acid. It's completely releases H plus ions. They are completely dissociated. So it's called as strong acid. Example, HCl, very known example, H2SO4, nitric acids. Okay, same, your strong base means completely dissociated in water and releases OH minus ions. Okay, completely dissociated and releases OH minus ion. Sodium hydroxide, potassium hydroxide. Okay, then your weak acid definition, basically the partially dissociated in water and meaningly only fraction of molecules releases H plus ions. मतलब not 100% or not completely dissociated in water. Okay, the some amount it will be a fraction and releases fraction of molecules and release to H plus ion. Example, acetic acid or citric acid. Okay, same your weak base. Weak base obviously the partially dissociated water and meaningly only the fraction of molecule releases the OH minus ion. Example, ammonia और methyl amine. अब नेक्स्ट मेन आता है आपका एसिडिक साल्ट. ओके, acidic salt basically the compound or the product of strong acid and strong base which dissociated to release H plus ions in solution and making it acidic solution. Okay, that is ammonium chloride forms NH3, weak base, or HCl means your strong acid. Basically acidic salt, whenever we use the word as acidic salt, that time always remember strong acid and weak base. The acidic salt is a product of strong acid or strong base. Okay, then basic salt. Basic salt basically again the product of your weak acid or strong base and which is dissociated with to release OH minus solution and making the solution basic. Obviously basic salt so having strong base. Example, sodium acetate from the acetic acid and NaOH solution. One of important neutral salt. Anyone guesses what is the product of? Okay, if you are guess, comment below. Neutral salt, basically a salt from the strong acid or strong base. Okay, it is a product of neutral salt. Basically, the strong, both are the acids or bases are strong, and which is dissociated into neutral ion and resulting in neutral solution. pH is equal to 7. That the both the cases and the both are strong. The basically sodium chlorides form the HCl is strong acid and also the NaOH is a strong acid. Okay. Then main part you have to see type of neutralization curve. So basically 8 types of neutralization curve. Okay. But in your syllabus only the 4 types of neutralization curve you have to learn. Okay. But my responsibility to teach you okay, how many types of neutralization curve. Okay. So basically 8 types. So how? First of all, how? The one is how means strong acid, strong base. Before that, we all know what is this diagram? Okay, right. There is a titration. Okay. In that titration, one is using a titrant and analyte. Titration basically between the your titrant, analyte, indicator, endpoint type. Last video, we are learn about this. So basically, why it's a 4 type? First upon strong acid and strong base. Strong acid and strong base. That the case is your titrant is base and analyte is acid. Okay, that means your strong acid, weak base, strong acid, weak base versus your analyte is base. Means titrant is a known solution. Okay, that's called as the first type. Second type, whenever you are identified your base, right? Means your analyte. That time you are titrant having a acid. That is a second case. Strong base, strong acid. Strong acid, strong base, weak acid. Then first of all, 1 minute. Okay. First, we have to show only the 4 main types: strong acid versus strong base, weak acid versus strong base. Yeah, strong acid versus weak base. Yeah, weak acid versus weak base. So first of all, strong acid, strong base. For example, we are using strong base hydrochloric acid, weak base sodium hydroxide. And the reaction between HCl, NaOH, the obviously formation of salt, sodium salt, and release the water. In description that the strong acid and strong base both are the acids. Both acids HCl and bases NaOH is strong electrolyte and dissociated completely in water. Right? Both are the strong. So obviously both are completely dissociated in water. The neutralization reaction goes completion and pH of changes rapidly near to the equivalence point. I directly goes to the diagram. Basically, we have to use NaOH HCl. In your y-axis, pH of your analyte, and your x-axis, value of NaOH added. Okay, so you have to continuously check the pH of your analyte. Okay, and when you are added drop-wise addition of your base means your titrant, that means here volume of your 0, 5, 10, 50, 20, 22, 24, 25. The one of the condition gets completely neutralized. Whenever both are the strong acids, both are the strong means strong acid or strong base, so obviously your neutralization takes place in 7. Okay, are you getting my point? If you are not getting it point, please comment. Second one is your weak acid and weak acid and strong base. So obviously, where is it is strong? Strong base. So example, let's you have to acetic acid and sodium hydroxide. Basically the reaction CH3 NaOH, the formation of sodium acetate. In that, in the titration, one of weak acid, another one is here. Weak acid obviously does not fully dissociated in water, right? But your strong base is obviously completely dissociated and completely gives OH minus ions. In that neutralization, initially pH is higher than strong acid. Okay, initially stage your pH is acidic, right? And when you are continuously added in a strong base means NaOH in weak acid, so obviously one stage have to completely neutralization because of where is strong base. Okay, so obviously your pH is about the 7. The pH above the 7 because conjugation base means acetate is weakly base. Okay, then next strong acid and strong base. Anyone guesses कि where your neutralization curve? Right, below to 7 because here is strong acids and here big base. Okay, then hydrochloric acid and ammonia reaction HCl NH3, the obviously formation of ammonium chloride. So obviously in the same case the strong acid is completely dissociated when dissolved in water and weak base is ammonia is partially dissociated when dissolved in water. The neutralization curve is startingly very low, right? Very low means pH below 2 3, okay, and continuously addition of a weak base again having below to 7. Okay, here I given some graph, right? When your acids, 1 minute, last next time I will explain. First I will cover this topic. Weak acid, next are weak acid and weak base. That time your example acetic acid and ammonia. Both are the weak, right? So both are the only partially dissociated, so there is less than 7 or greater than 7 basically according to the strength or according to the dissociation in water they formation, but basically they having neutral in 7 pH like strong acid and strong base. Okay, now I explain one of topic. And there is your, we saw this, right? Strong acid, strong base. Here, your analyte is acid, right? Next, your analyte, when you analyte your base, that time your curve having exactly the vice versa. So that's why I draw here. Strong acid, strong base, right? यहाँ पर वॉल्यूम ऑफ अल्कली है, यहाँ पर क्या है बेस है, तब कर्व आपकी ऐसी जाएगी ऊपर की तरफ, राइट? बट जब आपके एनालाइट में बेस रहेगा, राइट, एनालाइट में बेस रहेगा मतलब आपके फ्लास्क में बेस रहेगा, दैट टाइम योर पीएच ऑफ योर टाइट्रेंट तो ऊपर से ग्राफ आएंगे, ठीक है? क्योंकि बेस का इंपॉर्टेंट है ना, यहाँ पर देखिए नहीं समझ में आ रहा है तो बहुत सिंपल है। यहाँ पर देखिए स्ट्रॉन्ग है ना, ये देखिए ये सब स्ट्रॉन्ग एसिड आपके कहाँ पर है, एनालाइट में। और हम जो भी ग्राफ ड्रॉ करते हैं वो ग्राफ किसका होता है, पीएच ऑफ एनालाइट, राइट। तो इसका पीएच हम डिटरमाइन करते हैं और इसे ड्रॉप बाय ड्रॉप ऐड करते हैं बेस को। बट इन केस व्हेन यू आर योर स्ट्रॉन्ग बेस एनालाइट, तो एनालाइट बेस रहेंगे तो ऑब्वियसली बेस आपका 7 के ऊपर चले जाएगा, राइट। सो दैट्स व्हाई आपके जो भी ग्राफ आएंगे वो ग्राफ कैसे रहेंगे, ऊपर से रहेंगे। क्यों, क्योंकि आपका पीएच ऑफ एनालाइट क्या है, आपका बेस है, ओके। और आपका टाइट्रेंट में कौन आता है, आपका एसिड। वो सभी ग्राफ ऐसे ऊपर से आएंगे। पर जब आपका एसिड, हमेशा याद रखिए, जब आपका एसिड एनालाइट है दैट टाइम आपका पी ग्राफ हमेशा नीचे से ऊपर जाएगा, ओके। आई थिंक you understand. If you any problem or doubt, comment me. Okay. This summary: the titration type, strong acid or strong base. Obviously, both are the completely dissociated when you're dissolving water. So obviously, pH is equal to 7. Second, weak acid or strong base. Okay, weak acid or strong base. So obviously, your strong what is base. So obviously, pH is more than 7 because of there is conjugated base formation. Okay, again, strong acid and weak base. In that strong acid and weak base, pH is less than 7 because the conjugated acids are formation. Okay, and obviously last one is weak acid and weak base. pH depend on your strength because of if the weak acid is stronger, pH less than 7. If weak stronger is less than more than 7, is a pH is equivalent because of differently completely how much H plus ion and how much OH minus ions dissociated in water. Okay, thank you so much for watching. I hope you learned something new. Don't forget like, share and subscribe for more pharmacy tips and tricks. Thank you so much.